Hi viewers, welcome to NCK Hub Consulting and Training. As part of our Java 8 playlist, in this video, we will be discussing on functional interfaces in Java 8. So, how many types of interfaces are there in Java? There are three types. What are they? Normal interface, functional interface, and marker interface. First, let us discuss on normal interface. Until Java 1.7 version, inside an interface, we can have only public abstract methods and public static final variables. It means that if we try to add any other methods which are not public abstract, we will be seeing a compilation error. Similar way, if you are trying to declare any variables which are not public static final, you will be seeing a compilation error. But from Java 1.8 version, there are some additional features that were added to the interfaces. What are those? Along with abstract methods, we were also allowed to declare concrete methods with keywords default and static. So we are allowed to declare default concrete methods as well as static concrete methods. So from Java 1.8 version onwards, a normal interface can have any number of abstract methods, any number of default concrete methods, any number of static concrete methods. Let us take an example here. So here is an example of an interface, and this interface contains two abstract methods and one default concrete method and one static concrete method. So having said that interface can have static methods from Java 1.8, here comes a question. Can an interface have main method or not? Yes, from Java 1.8, interfaces can have main method as well. And here is an example for that. Here I took an interface. Inside that I have created a main method, and inside the main method I have provided a sysout. Let me try to execute this. I was able to execute this program and I was able to get the output as well. So we can execute an interface just like a normal class if it is having a main method from Java 1.8. Now coming back to the old example, here we have static method and we have a default concrete method and other abstract methods. What will happen if you try to execute this? This cannot be executed because there is no main method. As we know, JVM will always look for a main method while trying to execute the program. Since this program doesn't have any main method, we cannot be able to execute this part. This is more of a normal interface. Now, what is functional interface? Yeah, what is functional interface? An interface which can have only single abstract method and any number of default concrete methods and any number of static concrete methods is called a functional interface. So the difference between normal interface and functional interface is normal interface can have any number of abstract methods, but a functional interface can have only single abstract method. Other things are almost same for both the interfaces. Let us take an example for this. So this is a normal interface. Let us say I comment this particular abstract method. Now, this particular interface have one abstract method and one default concrete method and one static concrete method. Since this interface has only one abstract method, this particular interface will be treated as a functional interface. And from Java 1.8 version onwards, JVM has a capability of identifying the functional interfaces automatically. It means that whenever JVM comes across any interface with single abstract method, it automatically considers that particular interface as a functional interface. You might be having a question here. Is there a way we can explicitly tell the JVM to treat a particular interface as a functional interface? Yes, there is a way for it. We can use an annotation called @functional interface annotation. If you annotate an interface with @functional interface annotation, that particular interface will be treated as a functional interface by default. Let me show you an example for it. I'll remove, I'll uncomment this and let me show you an example of an interface which will have an annotation of functional interface annotation. So this is an interface with functional interface annotation. Now let us try to compare this both interface example and interface annotation as well. For time being, just let us not worry about this particular piece of code and try to compare all the other code in both the examples that I am showing. So here we have one abstract, one default, and one static, and we have one commented. And here also we have one abstract and one commented abstract, one default, one static. So, but the only difference between these two is this particular interface has @functional interface annotation, and here it doesn't have. But definition wise, from a JVM perspective, now both are functional interfaces. Now I'll try to remove the comment here first, and I did not see any error. Now let me go to this. This is the one which we have @functional interface annotation. And now let me try to remove this annotation. So remove the comments. Now see, JVM is throwing an error saying like this particular interface was declared using @functional interface annotation. And since you have declared more than one abstract method, this interface cannot be treated as @functional. It cannot be treated as functional interface. So having an annotation for an interface with @functional interface will help the programmer to not accidentally add any other abstract methods. If at all programmer is adding any additional abstract methods, immediately JVM will throw an error saying like, boss, this interface was declared with @functional interface annotation and it should have only single abstract method, but you are trying to add one more method here. That is not accepted. So now what I'll do is I'll try to comment this again and see the error was gone. Here it doesn't matter. So since it was not annotated, if it is a single, if it is having only single abstract, it will be considered as a functional interface. If not, it will be considered as a normal interface. That's the difference over there. Hope we are clear till this level. Now, the functional interface annotation is optional, but it is recommended. We have seen the reasons for it. One way it is letting the JVM know that this interface has to be treated as functional interface and it will be an additional check to prevent addition of more abstract methods. Now, let us see how can we implement these functional interfaces and the normal interface. Okay. Now, let us take the example here. We have this tester.java and we have this Imbal class and we have this test class. Okay. So these are the different implementations that we have that I have provided for all the interfaces that were created so far. So this tester.java is trying to implement this interrupt with annotation interface. And this is the interrupt with annotation interface. And this have only one abstract method. And this is a traditional way of doing the implementations. So we will be writing using implements keyword and inside the class we will be doing the override. That is one way of doing it. But if you see the same thing here, we are not using any implements keyword and we are not doing anything. Instead, we are directly creating an object for it And since it is a functional interface, what we are trying to do is we are trying to provide the implementation inside the main method itself by using a lambda expression. And there are other methods as well inside this. What are this? I mean, this print message is an abstract method, and we have default and static methods. So once the object is created by providing an implementation to abstract method using lambda expression, using the same object, we are calling the method for which implementation was provided, and then we are calling the default method, and then we are calling the static method as well. Since static methods can be called by class name itself, since this is an interface, we are trying to call that method using the interface name itself. Let me try to execute this program. See, we were able to get all the details. So this is the implementation that we provided. This is from default, and this is out from static method, and finally the output of the static method. So this is the way we can. And the normal interface, which have two abstract methods here. So we again will have to override this. And there is another way for this as well to implement this way. So since it is a functional interface, we implemented here. We just provided it using a lambda expression. But if at all if you have to create an object for this interface, what you need to do is you need to follow the concept of anonymous inner classes. And inside this here itself, we will be creating a main method. Inside that, we will be creating an object by defining the implementation as anonymous inner class for this particular interface. That anonymous inner class will have all the implementations for it, and that was the traditional way we used to follow for creating objects for normal interfaces. But for functional interface alone, using the advantage of lambda expressions, the process has become a little simpler. Hope we are clear so far. Now, let us take another concept here, multiple inheritance concept, which was not possible using the class in Java. So whenever we talk about inheritance using the classes, basically a class cannot be extended with multiple classes. It can be extended only with single class. And multiple inheritance with the classes concept is not possible because of the lot of ambiguities that we have. And let us try that concept using the interfaces. Okay. For that one, I have taken two interfaces here, interrupt left, interrupt right. Okay. So if you observe this, both these interfaces are functional interfaces. And if you see the implementation is more or less similar, except the debug here inside left interface, and here I have used inside right interface. Other than that, everything is same. There is one abstract method in both the interfaces, and hence both are the functional interfaces. Now what I'm trying to do here is I'm trying to extend these two interfaces with another interface. Okay, interface test will be this will extend with these two. Now, first, let me try to delete this particular piece of code and show you what will be the issue. So immediately when you write this particular piece of code, what the JVM will throw an error here is compilation error. It will ask you to override at least one of the default method from both of either of the interfaces, because we have given the same implementations for both. And even method names, method signatures, method definitions, everything is same. So what it is trying to tell you is, please override at least one of the methods so that the ambiguity will be resolved. So one particular approach here is to override the method completely, and you can come up with a complete different logic. The other scenario could be you can tell the compiler to pick a method to execute either of the interface that you want to. How do you do that? So if you see the syntax here, you are asking the compiler to go to interrupt right and followed by the super keyword, and you are asking to execute this particular method. You are trying to resolve the ambiguity by telling the compiler that for this particular execution, I want you to execute a method from interrupt right interface. You can ignore interrupt left. and I want you to execute the method only from interrupt write. That was the instruction that you are giving. And inside the main method, we are trying to create an object to an interface by providing the implementation to abstract method using the lambda expression. And then we are calling that particular method for which implementation was provided here. And then we are calling the default method as well. So for the default method here, we have asked the JVM to prefer the method from interrupt write. Now let me execute this program. See, if you see here, first we got the method implementation part, and then we got the debug from interrupt write. Now let me change it to interrupt left. Now let us try to execute this program again. Now if you see, it was trying to print the message from interrupt left. So this is one of the way we can try to implement the multiple inheritance concept, and ambiguities will not be there in case of any interfaces. But this is not possible in case of classes, but it is possible with interfaces. So this is one more example. And then coming back to our interface with annotation one, we missed to discuss this point earlier. Now I'm just trying to uncomment this. So earlier we were discussing like whenever an interface was annotated with address functional interface annotation, it should have only one abstract method. Then how are you able to declare one more abstract method here? If you clearly observe, this is a toString method and the return type is string. This is a method from java.object class. And even though we declare interfaces with that functional interface annotation, but this interfaces can still take the methods from object class, because these object class methods will have a default implementation. That default implementation will be applicable for these. That's the reason it is not throwing any error when we added a toString method to this particular interface. And let me try to change this toString to getString. So this will be considered as an abstract method. And immediately JVM has thrown an error saying like, this is a compilation error. You have added multiple abstract methods to a functional interface. Now if I get back to toString, yeah, it is resolved now. You are not seeing any error again. So that's the power of Ajare's functional interface annotation. It is very much recommended to have this annotation. And the other concept we would like to discuss here is what is the benefit that we get in the combination of lambda expressions and functional interfaces. Most of the boilerplate code will be reduced. For that, I have an example here for creating a thread. Okay, so I created multiple threads here. One thread using the concept of anonymous inner class and providing an implementation to runnable interface using anonymous inner class, and the other concept is using the lambda expression. Okay, now if you see the code directly here, I'm trying to create a thread, and inside that, I'm just trying to create an anonymous inner class, and I'm trying to provide the implementation, the child thread. Similar case, if you see with lambda expression, the number of lines of code that we are writing is reduced, and this is a simple example that might be the reason you will not be seeing more difference. But if you see the complex logics, you'll find a lot of difference. But for a simple example itself, you see, I'm not using any runnable here or anything as such. But still, we were able to, but still JVM is able to understand for which particular method we are trying to provide the implementation using the lambda expression, and it is still being executed and it is giving correct output for us. Let me try to execute this program. See, main thread and the first child threads and second child thread. That's how we were able to achieve the or reducing the boilerplate code with lambda expressions in the combination of functional interfaces. And regarding the default methods, what is the main reason to have default concrete methods inside the interfaces starting Java 1.8? Let us take a use case. You are working on a project and you have an interface with abstract classes, abstract methods, maybe 4 to 5 methods were there, and you have written some 4 to 5 implementation classes, and you have provided different implementations based on the requirements. Suddenly, there was another requirement, and you are supposed to add another method to that particular interface. So, adding a new method to that particular interface will result you in changing the code for all the implementation classes. Whether you need or not, you still have to override that. Now, let us say that new method which we were adding can be added as default concrete method. You can give some sample implementation, maybe in some kind of logger or debug message or whatever it is. That way, you need not modify the existing implementations and you can just concentrate on the new implementations. Since that is a concrete method, JVM will not throw any error and it will not force you to override that method inside the implementations which are already completed. That's one of the major advantage of having default concrete methods. And these default concrete methods will be available to all the implementation classes like how abstract methods are available. There is no difference between those two. But the only advantage is it will not force you to override the methods. If at all we wanted to override, we can do it, or else we can leave it like that. That's the major difference. That's all for this video, and thank you very much for watching it.